Page 2, find the domain. The domain is the values of x that this function is defined for, which means there's y's for. Well, there's y's for -6 all the way up to 8 except for at 5. So we have to somehow describe all the numbers between -6 and 8 except 5. In interval notation, that would be from -6, including -6, up to 5, but not including the 5, union with, now we go on from 5, but not including the 5, up to 8, including the 8. That would have been interval notation for it. Set notation would be a little bit harder. The set whose elements are numbers such that -6, we can do it in a couple ways here. I'll do it this way first. -6 is less than or equal to x, which is less than 5, or 5 is less than x, which is less than or equal to 8 in set. Or I could say the set whose elements are numbers such that -6 is less than or equal to x, which is less than or equal to 8. That's all of these. Intersect, or and. So I can take all these, but they also have to be in this next set, and the next set I'm going to describe is all the numbers that are not equal to 5. All the numbers that are not equal to 5 are all of these numbers, and the numbers that are between -6 and 8 are these numbers, and where they overlap is all these except the one set doesn't have 5, so we'd have to leave it out. So we could write it this way, or that way. Find the intercepts. Well, there's an x-intercept here. It looks like about -4.5. 0. Intercepts are points. They should always be reported as points unless they ask otherwise. There's a y-intercept here, about 0 for the x, 3.5 for the y, about. And there's another one up here, looks like about 7.6 or 7.7. 0. 3 of them. Evaluate, which means says, find the value of y when x is 3. When we go out to 3, and the y value looks like about 2.9. Find the y value when x is -2. -2, it looks like it's about 5.2. Notice I'm not writing a point. The y value is not a point. The y value when x is -2. A max or a minimum. A maximum, a local maximum, is any place where the has to run off either side, where that would be there. And the maximum is a y value. How high? What's the maximum height? And that happens to be about 5.3-ish. If you want to tell me it happens at -2.4 or something like that, say at x equals -2.4, that's cool, but you don't have to. Local minimum. Well, that's not a local minimum because it can spill off the ends, but there's a local minimum in there, and it looks like it's right at about 2, but I don't ask for that. I want to know the y value, which is 2.8-ish. It's approximately 2.8. I'll put a dot above these for approximate. You could tell me at x equal 2, but you don't have to. Absolute maximum. Is there a very top of this thing? And is it defined? Yes, it looks like about 5.3. You can tell me at -2.4 or whatever you read that as, but that's it. approximately. And what's the absolute minimum? That's the very lowest part on the graph. And the very lowest part looks like it's at -2 in 2 places. So I could say -2 is the very lowest y value. And I could say, if I want, but don't need to, at x equal -6 or x equal +8. But -2 is the only thing that was critical there. All right. Some people made this oh so difficult, and they did some stuff right and some stuff not so right. I'm just going to draw the y-axis, the x-axis, and you got all tangled up with drawing this. This is y equals 2x. Y equals 2x. If I make a table, if x is 0, I get 0. 1, I get 2. 2, I get 4. 3, I get 6. 3, I get 6. 0, 0. 1, 2. 2, 4. Oh, I've got a pattern established here. Back 1, down 2. Back 1, down 2. Back 1, down 2. Back 1, down 2. So it's going like this. But now, and this is where people got messed up, it says x. Forget the y's. Forget how high. The x, the domain, the x's have to be less than -1. There's where x is -1. We want to use x values over here. Not at -1, but every place otherwise. And so I should have an arrow head on it and make sure I know that that's -1, and this is +2, and this is 3 up there, and this is -2 here. So I got some units on my graph, as it says to do. Now let's do the other one. Y equals 1 minus x. I can also do like 0, 1, and 2, and 3, and try to figure out where this line roughly goes. So if I put 0, 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 2 is -1. 1 minus 3 is -2, etc. 0, 1, 1, 0, and so on. So this line goes like this, slope of -1. But I'm only supposed to do it from -1 in the x. This is x's. -1 in the x, which is right about there, to +5. So I have to draw it from here to x equal 5 is here. So I'm going to stop the line there, and I'm going to make that line look dark. That's where I'm going. Solid circle, open circle. So there is my graph. Now, to draw this, I used some points that weren't in the domains of these, but that was just to locate the line, because I knew there were lines. Now, intercepts. Looks like it's 0, 1, and 1, 0. At 6. 6 is not in this domain, 6 is not in this domain. You can see it on the graph. There's no place for 6, undefined. At -1, I can look at the graph, and at -1 it's up at 2. Or I can look here, -1, I plug it not into this one, but it can be -1 here, so 1 minus a -1 is 1 plus 1, which is 2. This is not asking for a point. It's just saying, what's the y value at -1? And what's the y value at -4? -1, 2, 3, 4. Well, we got, that goes into this one. 2 times the -4 is -8. And if you graph this far enough, you would get to -8. Down 2. 2 more to get to
the extra one. Okay? That's page 2.